Hello students, I am Vishwajit Nath. Welcome to my YouTube channel Best Physics Guide by Vishwajit Nath. Today I am going to discuss about the moment of inertia of a body. Let a body rotates with respect to an axis y prime. m1, m2, m3 mn are the particles inside the body. Capital M be the total mass of the body. That is, mi is the mass of the ith particle and ri is the normal distance between the particle and the y prime axis. Here I is equal to 1, 2, 3 up to n. That is, the normal distance between the first particle and the axis y prime is r1, and normal distance between the second particle and the axis is r2, and so on. Now the moment of inertia of the body with respect to y prime axis can be defined as I is equal to m1 r1 square plus m2 r2 square plus plus mn rn square, or I is equal to summation of mi ri square, where I is equal to 1 to n. In terms of calculus, we can write I is equal to integration of r square into dm, where dm is the mass of the small portion of the body and r is the normal distance between that small portion with the axis of rotation. Now let P be a point inside the body and K be the normal distance between the point P and y prime axis. Now if moment of inertia of the body will be I is equal to mk square, then K is known as the radius of gyration of the body with respect to the axis of rotation, that is y prime axis. That is, mk square is equal to summation of mi ri square. From this relation we can easily find out the value of k. Let this is a body which rotates with respect to the axis AB. O is the center of mass of the body, and the axis AB passes through the center of mass of the body. CD is another axis parallel to AB. The normal distance between AB and CD is D. Since AB is an axis of symmetry, AB is an axis of symmetry of the body. Therefore, summation of mi ri is equal to 0. Summation of mi ri is equal to 0. Where mi is the mass of the ith particle inside the body and ri is the normal distance between the axis AB and that particle, that is ith particle. Now the moment of inertia of the body with respect to the AB axis is I0, and the moment of inertia of this body with respect to CD axis is I. Now according to definition of moment of inertia, we can write I0 is equal to summation of mi ri square, summation of mi ri square, and I is equal to summation of mi ri plus d whole square, where ri plus d is the distance between the ith particle from the CD axis. Now we can easily write I is equal to summation of mi within whole bracket ri square plus d square plus 2d into Ri within whole bracket. This is equal to summation of mi Ri square plus d square summation of mi plus 2d into summation of mi Ri. Since d square and d are constant, therefore they can be placed outside the summation. This is equal to, from the definition of I0 we can write that summation of mi Ri square is equal to I0, and summation of mi is the whole mass of the body. This is equal to m, capital M, the total mass of the body, that is m into d square plus 0. Why? Since we know that summation of mi Ri is equal to 0. Therefore, we can write that I is equal to I0 plus m d square. This is known as parallel axis theorem. Now, perpendicular axis theorem. Let P be a point on a body. OX, OY and OZ are three mutually perpendicular axes. O is the origin. Now, PA is normal to OX axis, PB is normal to OY axis, and PO is normal to OZ axis. OA is equal to XI, OB is equal to YI, and OP is equal to RI. Now, the mass of the particle at the point P is Mi. The moment of inertia of the body with respect to OX axis is Ix, with respect to OY axis is Iy, and with respect to OZ axis is Iz. Now, according to the definition of moment of inertia, we can write Ix is equal to summation of mi yi square, Iy is equal to summation of mi xi square, and Iz is equal to summation of mi ri square. Since Ri is equal to xi square plus yi square, and Iz is equal, therefore Iz is equal to summation of mi whole into yi square plus xi square. Therefore, we can write Iz is equal to summation of mi yi square plus summation of mi xi square. This gives Iz is equal to Ix plus Iy. This theorem is known as perpendicular axis theorem. Today, I am going to complete my discussion. In the next video, I shall discuss about the moment of inertia of different type of bodies. Thank you for watching my video. Have a nice day and please subscribe my channel.